Recently, we talked about finding characteristics of graphs, and characteristics could be anything from the x and the y intercepts to local or relative maximums and mins. It could be increasing and decreasing intervals. It could be where the function is greater than 0 or less than 0. So this video is going more specifically into how to find roots or x-intercepts, how to find them by hand without using a calculator. And we're going to focus in this video specifically on finding real roots, and then the next video we're going to focus on finding complex roots, or like fake roots, roots that don't actually show up when you graph. So first, I want you guys to go ahead and write down the different synonyms or like directions that you would see for problems like this. So we're going to call them x-intercepts. Roots, I already said. They can also be called zeros of the graph. I don't know if it's ES or just S, so feel free to put the E if you want. And then they might also say just solve for x. So if they ask for an x-intercept, I always want you to write the solution or your answer as a point. An x-intercept is a point. For the rest of these, if it says find the roots or find the zeros or solve for x, then when you write your answer, you can just say x equals whatever it equals. Okay, so that's something that I would like for you to keep in mind. Okay, so this video is basically all the different ways you can factor, because when we find real roots by hand without a calculator, we're going to be doing it by factoring. So the first type of factoring that I want to remind you of is GCF, or greatest common factor. So let's say we have a function y equals, that's an equal sign, let me fix that, y equals 3x squared minus 9x. Then what you would do for this is you would say, okay, I'm going to take that and set it equal to 0 so that I can find the roots or the zeros or solve for x. So I'm going to say 3x squared minus 9x equals 0. So I'm replacing the y with a 0. The GCF of this function between 3 and 9, I have a common factor of 3. Between x squared and x, I have a common factor of x. So I'm going to go ahead and write those first. And then I'll put my leftovers. So if I did 3x squared and I divided out a 3 and I divided out an x, then that would mean I have a leftover x. If I have negative 9 and I divide out a 3, that leaves me with negative 3. And I had an x and I divided out an x, and so that's gone. So I took out the GCF. At this point, we would go ahead and we would take each factor and set it equal to 0. So 3x equals 0, and x minus 3 also equals 0. So for 3x equals 0, if I divide by 3 on each side, that gives me x equals 0. And if I add 3 to each side, that gives me x equals 3. So my two solutions would be 0 and 3. You don't have to show that in between work. So anytime you see something in the front, an x in the front, it doesn't really matter what the coefficient is. If the x is in the front, you're going to end up dividing this coefficient out, and that x is always going to equal 0. So if you want a shortcut right to that, you can. For this factor, you can see that we added 3 to the other side. So if you want a shortcut and just say it's the opposite sign, you're welcome to do that. All right, so that was GCF. We're going to go ahead and do another type of factoring. This type I call the diamond method. Not everyone calls it the diamond method, but pretty much everyone means the same thing by it. So y equals x squared plus 11x plus 30. So to do this problem, we're going to look for two things that multiply to 30 and add to 11. The two numbers that multiply to 30 and add to 11 are 6 and 5. And so our factors are x plus 6 and x plus 5. And just like the previous problem, in my head I was thinking that I set this equal to 0. That I set this equal to 0 right here. So I'm like, oh, that equals 0. I just didn't write it this time because it felt a little bit redundant. So sorry I didn't say that. Okay, and then I can go ahead and say what my solutions are. I have x equals -6, x equals -5. So there are my roots or my zeros or my solutions. The reason this is called a diamond, the diamond method, in case you're curious, is that if you do this right there, it's a diamond. That's why they call it that. It's a stupid looking diamond, but that's why it's called the diamond method. True story. Anyway, okay, take that away. It's ugly. Okay. All right, next method. You can use guess and check for these if that's your preference. I am not a fan of guess and check. I like to do slide, divide, bottoms up. Some teachers really hate that I teach this, but really you can do what's comfortable to you. So I use slide, divide, bottoms up anytime I have a trinomial that has a number in front of x squared. So you'll notice for the diamond method, those are like the simple problems that x squared is all by itself. Here I have a 2 in the front. So anytime we have a coefficient for that x squared, we're going to take this number right here and we're going to slide it over and multiply it by that number. So I have 2 times -15 is -30. And so I'm going to multiply to -30 but add to -7. So the two numbers that multiply to -30 but add to -7 would be -10 and 3. That took me a second. Oh gosh. -10 and 3. Okay, so I'm going to go ahead and write that in my factored form. I have x minus 10 and x plus 3. And so I did the slide part. Now I have to do the divide part. So I'm going to go ahead and switch back to purple. So the number that you slide is the number that you divide. I slid a 2, so I'm going to say divide by 2 right here and divide by 2 right there. So now I've got two fractions. I have 10 halves and 3 halves. And my next job is to simplify those fractions. So 10 divided by 2 is 5. So that leaves me with x minus 5. And then the second fraction is 3 over 2, and that fraction cannot be simplified. So I'm just going to leave it. When you have a set of parentheses like that that is left with a fraction, that's when you do bottoms up. So the bottom moves up to the front like that. So 2x plus 3. All right, so there's my factors, and then I can go ahead and write my solutions now. So I'm going to do the opposite sign. X equals positive 5. For the other one, it would be x equals -3 divided by 2. I'm going to go ahead and write that, and then I'll show you where that came from. So -3 divided by 2. So there's my two solutions. If you are not convinced that it really should have been -3 divided by 2, the work that you would do there is you would say 2x plus 3 equals 0, and you would subtract the 3 over, so 2x equals -3, and you would divide by 2. X equals -3 over 2. So if you want to show that work, you can. If you've done it often enough that you can say, oh, just change the sign and divide by the number in front of x, you can do that as well. It's up to you. Okay, we've got another type of factoring called difference of squares. You should be pretty familiar with that. So here, I'm going to say that we're doing y equals x squared minus 25. So whenever you do difference of squares, you get two sets of parentheses, one with a plus, one with a minus. So we've got x plus 5, x minus 5. And so my two solutions here would be -5 and +5. So that was pretty simple. I'm going to do another one for difference of squares because I want you to see that you can do difference of squares even if the number is not a perfect square. So as teachers, we've always told you in the past not to do it. But if you're using that method to solve, you can still solve it if it's not a perfect square. So I'm going to show you. So here, if you look at this next problem that I wrote, we do have a GCF of 2. So I'm going to go ahead and take out that GCF. I've got 2 times x squared minus 10. And then here you'd be like, Ms. Rice, that's not difference of squares because that 10 is not a perfect square. However, you can still use the same idea. So I'm going to have 2 sets of parentheses, one with a plus, one with a minus. I've got x and x. So before we said, oh, the square root of 25 is 5. So we put 5 in the parentheses. Here, I'm going to say the square root of 10 is the square root of 10. And I'm just going to write square root 10, square root 10. And that, my friends, is how you do difference of squares with something that's not a perfect square. It's not too hard. So here we can just say, all right, my solutions are negative square root of 10 and positive square root of 10. Okay, so if you see a problem like that and you want to go ahead and use difference of squares factoring to solve it, you are more than welcome. All right. Okay, and then we have one last type of factoring that is going to be probably new to you, but it shows up often enough that we can't ignore it. And that is called factoring by grouping. Okay, so I'm going to go back up here. We're going to add a little something to your notes. I'm going to put this in pink. GCF happens all the time. So you are always going to look for GCF. Always, 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 always. Okay? With the diamond method and with slide divide, we do that when we have 3 terms. So 3 terms for this one, 3 terms for this one, right? First term, second term, third term. First term, second term, third term, right? Difference of squares, you can see it only has 2 terms. So that's kind of what we look for. We look for perfect squares or maybe even not perfect squares. And we look for that minus sign in the middle. There is no such thing as sum of squares. If you have x squared plus 4, it is not factorable. In fact, we're going to go ahead and write that. X squared plus 4, x squared plus 36, x squared plus 100, all of those are not factorable, okay? So factor by grouping, you'll be able to recognize because it's going to have 4 terms in it. Oop, there we go, 4 terms in it. That's how we're going to recognize factor by grouping. All right, let's go ahead and write the example problem that we're going to do. Y equals 24x to the third minus 21x squared minus 64x plus 56. Okay, so what we do is we take the function and we split it in half. First 2 terms, second 2 terms. And we treat them like 2 separate problems. So the first term, if you look between 24 and 21, the first term has a GCF of 7, 6, 4, I'm struggle busing here. 3 has a GCF of 3. Yeah, I think that's it. 3 times 8, 3 times, yes, 3. So we're going to take out a 3. Between the x to the third and the x squared, it has a GCF of x squared. So I'm going to go ahead and write that, 3x squared. And then I'm going to put my leftovers. So 24 divided by 3 is 8. X to the third, take out an x squared, that leaves me with an x. 21 divided by 3 is 7. I have an x squared, but I took it out. Okay, so this has become, this is my new first term. Okay, that's a first term. All right, I'm going to go ahead and do the second part. So between negative 64 and positive 56, My GCF is -8. And then I'm going to go ahead and write my leftovers. So -64 divided by -8 is +8, and there's still an x. +56 divided by -8 is -7. This is considered to be my second term. Now, if you look, you can see that my two parentheses match, right? And that's a good sign. They always should. When you do factor by grouping, they will always match. So the idea with factor by grouping is that if the green is my first term and the blue is my second term, then I have a GCF between the two terms. This factor and this factor is common. It's a common factor between the two terms. So they say, all right, between the first term and the second term, this is the GCF. So I take it out and I put it in front. And once I've taken out the GCF, I put parentheses and I write my leftovers. I have a leftover of 3x squared, and I have a leftover of -8. Right? So that's how you do factor by grouping. All right, my first set of parentheses is ready for me to solve. X equals +7 divided by 8. My second set of parentheses, I'm going to go ahead and factor using difference of squares. So I'm going to have two sets of parentheses, one with a plus, one with a minus. The square root of 3x squared is going to be the square root of 3 times x. The square root of 3 times x. Right? The square root of 8 is just the square root of 8. Okay? So now I'm going to go ahead and solve those. I get x equals the negative square root of 8 divided by square root of 3, and x equals positive square root of 8 divided by positive square root of 3. This part that I'm doing right now with this difference of squares and this extra factoring, that's not something that always happens in factor by grouping. It's certainly possible, but it's not necessarily always true. Okay? So if you recall, you're not supposed to leave a square root on the bottom of a fraction, so I'm going to go ahead and fix it. I'm going to multiply the top by square root of 3. I'm going to multiply the bottom by square root of 3. So multiply the top square root of 3. Multiply the bottom by square root of 3. And so that leaves me with negative square root of 24 divided by 3. And positive square root of 24 divided by 3. And technically the square root of 24 should be, like, we could simplify that, and normally I would, but I feel like this might have been overwhelming enough as it is. So we are going to go ahead and leave that, and I will stress simplifying square roots later on in the unit.